Hey, okay, so it's week 12. I'm looking at Sean Doty's response here. I need some help with week 12 homework problems and a quick explanation. So let's look at the quiz through topic 10 questions 1, 11, and 12 first. And I am not going to solve this, but let me, because it looks like only 2 attempts have been made. There's still 4 left to be done, but let me, he said 11, and 12, right?
Yeah.
Okay. All right, you are provided 6 annual payments. Each payment provided at the end of each year. What is the present value of the group using a discount rate of 5.5%? I don't mind just solving this one. Let me just see. Let's just do it. I don't care. Start from scratch. Yeah. Okay. Now here's how I would do that if I were digging into this. Okay. So I'm just going to take my equivalence factor file, save as, LU2, bop up here. This is going to be quiz 11. Question 1. And let me see if I can get a text box going there. Insert, text box. Text, there we go. Oopsies. Insert control Y. Take this guy, drag it up here. Insert Y. Okay. 6 annual payments. This is a little smaller. Might have to go over here to shrink it. So what we're going to do, since these are just so random, they're going to have to be done as 6 separate problems. That's the only way I can see how to do it. So what I'll do first is I'm just going to delete all this stuff because I've got a new question. I know that I'm looking at 5.5%. I don't want present future. I don't want future present. I don't want future annuity. And I don't want that either. What I want, and sometimes I can't remember if it's AP or PA, but this is the small value, this is the big one, and it's the big one we want. Because the annuity is always going to be smaller. Okay, so I don't want this. Okay, so I've just, I've taken the thing and simplified it. Now, let's see, if I, thousands of dollars, what's the present value, 5.5%. So let's just put in 1,500 for the first one. And it's just 1 year. Okay, so that makes sense. Well, there's probably some really simple way to do this. Oh, yeah. Yeah. And I just screwed it up because it's actually a future present value. There's only one payment that far in the future.
It's 6 of them, right?
It's 6 of them. It's 6 separate future present value problems.
For each one?
Yeah, yeah. So I unfortunately deleted.
Thanks.
Yeah, let's go back and I think, okay, so here's future. So the present value is going to be so the present value is going to be less than the future value because the amount is increasing. It's going to be worth $1,500 in the future, so it's $1,400 now. Let's look at this one. I'm just going to pop in another. So if we had 8,000 in 2 years, let's do that here. 5.5, 2 years, 8,000. That's the okay. So we're gonna have $8,000 in 2 years. That means at 5.5%, we invest 71.8762. So let me just take this guy, this chunk right here, copy it, come over here, down here, paste it. Shift cells left, fine, okay. Oops. Shifts. Okay. Yeah, so actually from here it's just getting to that 6th year. Three, 4, 5, 6. So all I was doing, I was just doing Control V to paste those in there. And we know that each one is, so here's 6, here's 5, here's 4, here's 3. And now it's just a matter of going up and seeing what those values were. So the 3-year was 4,000. Year 4 was 2,500. Year 5 was 3,500. And then year 6 was 8,000 again. Okay. So now I should be able to just say equals sum. I think just grab this whole column now. What is it? It's just deep. Jeez. Equals sum, open paren, close paren, 22K. Is that an answer? 22. So that's how I'd do it. It threw me at first, like, wait, there's no, it's not clear because it's not really a true annuity problem. It's just a set of 6 present value, future value problems. It works with the PA function because it's only one.
Right, but then you gotta add them all up.
They just add them all up, exactly.
Okay.
Yeah. And you can see that this $8,000 problem for 2 years, it's got a present value of 7,200. But if you run it for 6, it's got a value of 5,800. All right, I like that one.
Your 2-year one?
2-year came out with 7187. Yeah. All right, that was fun. Question 1, check. Okay, and I'll just read through this rather than solve it. A utility offers an incentive to a customer for a project that saves 150,000 kilowatt hours per year. This is going to be an efficiency thing, or maybe they're changing light bulbs or something, and has a project cost of $50,000. Excuse me. The incentive is based on the lesser of 12 cents per kilowatt hour for 1 year, or 70% of project cost. Energy cost is 7 cents per kilowatt hour. You know what? We got to solve this one too. Sorry, just can't help myself. Got to do it. It's too tempting. These are good exercises. I mean, seriously. So let's just figure it out here. No guarantee it's right, but I'll take you through the thought process. Okay, so we're going to run this thing for 15 years. It's going to save this many kilowatt hours per year. This is the present value cost. You're either going to save 12 cents per kilowatt hour per year, every year.
For 1 year.
Does it just go away after 1 year?
That's what it seems like to me.
Okay, or 70, yeah.
Or 70% of the project cost.
Energy cost is 7 cents per kilowatt hour. Utility discount rate is 6.5%. Project is. What's the utilities levelized cost in cents per kilowatt hour? All right. This probably looks a lot like another problem, but I don't mind just starting from scratch. This is actually P1. I'm going to call this P11. So I'm going to start here, go up here, copy this, come down here, paste it there. It's kind of funny, I was with this guy yesterday, and he's like, you know what, guys, I am so good at Excel, you won't even believe it. And he was quite good, but he comes in and he had a pretty sophisticated spreadsheet, had like 20 tabs on the bottom, it's a bunch of different costs. And I don't think it had interest rates or anything like that, but the poor is of course is all bragging, and then the what's the utility in kilowatt hours, and then something didn't work. It was kind of embarrassing, but it happens. Don't be embarrassed. Just keep working. Okay. It's a waste of time. Cancel. Paste. Okay, so we're looking for 150. Man, that's a big project. And I strongly encourage you to use the right units on that. Savings, capital. This is dollars. 50. Scenario 1. Sometimes it's hard to talk and think at the same time. I'm just putting the variables in though. So right here, so we don't really know what the total energy per year consumption is. We just know that we're going to save 150,000 kilowatt hours per year. So we're going to save $10,000 per year. It's 7 cents per kilowatt hour. The discount is in a percentage, 6.5. Control 1, we'll put that in as a percentage. Okay. 6.5. Control 1 decimal place. Okay, okay. N. This is in years. 15. Okay. So this is basically the annuity. You've got basically a $10,000. So this is the $10,500 per year annuity that you're more or less saving. So let's just put in the capital. In both cases, that just equals your project cost. Perfect. Now, in savings 1, incentive is based on the lesser of 12 cents per kilowatt hour. So does this mean they're going to pay you 12 cents per kilowatt hour for every kilowatt hour you saved? I don't see any other way to do it.
It must be, because they're not going to just pay you 12 cents a kilowatt hour per year that you produce.
Well, yeah, what they're doing is they're paying you to not burn it.
Right.
Yeah, they're saying, hey, it's going to take the load off the utility. Yeah, okay. So this is the incentive. This will also be the incentive rate. We'll just say incentive rate. It's going to be in dollars per kilowatt hour. What is it, 12 cents?
Yep.
Let's see, 12 cents. Okay. So the incentive is just 1 year. Now, I'm not sure if this needs to go into a present-future formula because they might not pay it until the end of the year. I don't know if they're going to save you 12 cents per kilowatt hour for electricity they think you're going to save after the end of 1 year.
Right.
Let's see, though. 12 cents for 1 year. Well, let's just run it without the PA and with. And let's just say, and I'll just call this PP. And we can also run it PA. So PP just equals the kilowatt hour per year savings times 12 cents. What's the, I gotta find that function. Unit value. I'm going to use this formula right here, I think, just to calculate it the other way. It's a PV. So, yeah, so it's a P, I'm going to try it as a PV. So it's the, so it's basically that amount times PV, open paren, the rate, payments, oopsies. Oh, it's actually, so C13, it's only 1 year though. Yeah, that makes more sense.
It's not the 15.
Yeah, because it's the 1 year. So basically, 18 grand at the end of the year is worth 16.9 right now.
Gotcha.
So it's going to be one or the other of those. So I'm just kind of hedging my bets to make sure I did them both right. Okay. Or, so this is, now we're doing the or 70% of project cost. Just pop it in there. So here's our 70% equals, think, times 0.7. Now, this thing is actually negative, because that's a cost. This is negative, because that's a cost. Now, it's going to save energy for 15 years. We might have enough information already. And we might just be able to see that, we'll do the whole thing, but it might just be like, hey, saving 35 grand is better than saving, either 18 or 16. I would almost say that, there you go, just go with that. But let's just see what the, PV of annual savings. Equals, so the annual savings is this, times PV, open paren, number of periods is 15. Wait a second, no. Oh, rate. Number of periods is 15, there we go. That's the same. I mean, I think the savings over time is going to be oh, what is the utilities levelized cost? Okay, here we go. Now we do this. Levelized. All right. Okay. Who's paying the 50K up front? It's not clear. It's just the whole shebang, maybe. Let's see. So, is the trying to make sure everything, the things that are negative are in fact negative. This is not an easy problem. Currency, take, equals, take. Currency. I'm going to pause it so I can think. Okay, this was not an easy problem. I think I got the thing figured out here. Joe and I just worked through it. So let me show you my thought process on it. I went ahead and flipped these capital. So I don't think the capital comes into play. It's basically the user is going to pay $50,000 up front, so the utility doesn't even really see that money. The only way they see that money is in one of two ways: is to pay 12 cents per kilowatt hour saved. So basically, they're saying the bigger the project you make, the more we're going to subsidize it. Fine. If you just go straight up present, then that amount if you just go present, then that amount is 155 kilowatt hours per year times your 12 cents, that's $18,000. But if you say you're not going to get the money back until the end, and you're running at a discount of 6.5, it's going to be a little less money now. So those are the two costs to the utility, or it's going to be one or the other. The other option, 70% of the project cost, means that the utility is going to just pay you back 35 grand and you only spent 15. Fine. So now what we want to do is say, how much is this saving the consumer? Because why would you do it unless it's going to save you? Well, shoot, that's a pretty good payback. If you're going to save $100,000 a year, why would you not, drop the 50K now, especially if you're getting a payback? Well, the utility wants to pay you the lesser of the two, so the utility is going to select this one. Because they're only have to pay $18,000 instead of $35,000, which is 70% of 50. Okay. In both cases, you, the ratepayer, are going to save this much, which was the present value of your annuity. That's how, 10,000, you're going to save $10,000 per year. Sorry, yeah. It's $100,000 savings overall. You're going to save $10,000 a year, so it's more like it's more like a 5-year payback. Right. Okay. Scratch what I said before. Times C11, which is the interest rate, 6.5%. You're going to run that for 15 years, and there you go. So the present value of the annual savings is almost $100,000. So right off the bat, you double your money. Right? Okay. Good deal. If you got 50K sitting around. Now, I ran this in a couple different ways, and I realized that in the first scenario, I tried a levelized cost, which equaled the savings, which I interpreted as how much the utility was going to lose, because they're not going to get that $100,000 from you, plus the incentive. None of those answers came out, because when you levelize it that way, because the total kilowatt hours of savings is 2.2 million. That's just 150,000 kilowatt hours per year times 15 years. So if this total sum were the levelized cost divided by the total kilowatt hour savings, this would be the levelized cost. But none of those, and each one of these cells I just copied down from above and put the significant digits at 2. So if this were our multiple choice, 5, 6, 7, or 8 cents per kilowatt hour, none of them are correct. So that's not the right way to interpret it. So I redid the problem and said the only cost to the utility is going to be what it pays you that first year as an incentive divided by the total kilowatt hours. And in that case, we come up with, 0.1, and we can just do it this way, control 1. If you change that to a single decimal place, it's a penny per kilowatt hour. This other scenario is not going to fly because they don't want to pay you the 35K. So the answer here should be just that 1 cent. All right. Not an easy problem. Let's read I'll take a break and then I'll read number 12.